Clay Township Regional Waste District was created in 1975 as a nonprofit municipal corporation whose purpose was to provide effective and efficient sanitary sewer service to our customer base. 40 years later, Clay Township still strives to provide effective and efficient sanitary sewer service and provide an infrastructure for environmentally sound development. When you use the sink, take a shower, or flush the toilet, that water is collected, treated, and returned back to the environment. The water that washes down these pipes of homes, businesses, and industrial facilities is collected in a series of pipes called the collection system. The collection system conveys water away from the building and ultimately to the wastewater treatment facility. At Clay Township, the collection system is comprised of nearly 300 miles of sanitary pipeline. Wastewater flows through these pipes mainly by gravity until no longer feasible to go deeper, at which time lift stations pump the wastewater to higher elevations in order to allow gravity to take over again. Larger pressurized pipes called force mains convey the wastewater to the treatment facility for further processing. Clay Township's treatment facility is located on 18 acres of land. In 2009, Clay Township converted 10 of the 18 acres into a wildlife-friendly habitat by planting native Indiana wildflowers and prairie grass. The first part of the treatment process is called the headworks. The goal of the headworks is to remove large inorganic matter from the wastewater. 2 large mechanical step screens filter out large debris such as rags, food, and other trash. The removal of this large debris helps pumps and pipes in the plant from getting clogged and damaged. The trash collected from the step screens is loaded in a dumpster and collected for disposal in a landfill. The wastewater then flows to an influent splitter structure where the raw wastewater is mixed with microorganisms to treat the pollutants in the wastewater. This process of treating wastewater with microorganisms is called activated sludge. The influent splitter structure splits flow between 2 aeration basins, the orbital oxidation ditch and the vertical loop reactor, or VLR. Approximately 1/3 of the daily flow is treated by the orbital, while the remaining 2/3 is treated by the VLR. The orbital is a concentric loop design that allows the microorganisms to remove pollutants such as phosphorus, ammonia, and BOD throughout the treatment process. The activated sludge flows hydraulically from the outside loop towards the center. Aeration discs are positioned in the center of the orbital to provide ample oxygen to the microorganisms throughout the process. Probes are used throughout the orbital to monitor oxygen levels. Once the activated sludge has reached the center loop, it flows over a level controlled gate and continues to the clarification process. To increase treatment capacity and allow for better biological phosphorus removal, Clay Township went through an expansion in 2004 and built the vertical loop reactor. The VLR is designed with looped reactors in series. The loop design is created by a horizontal baffle that runs the center of the tank. The VLR is similar to the orbital, but instead the design has been flipped on its side. The VLR uses the same type of aeration disc as the orbital, but also utilizes coarse air diffusers to supplement oxygen demand. Once the activated sludge has reached the end of the 4-reactor series, the activated sludge leaves the VLR and proceeds to clarification. At the end of the orbital and VLR process, the activated sludge enters a splitter structure that distributes it evenly to the clarifiers. The clarification process includes 3 40-foot clarifiers that are dedicated to the orbital and 3 70-foot clarifiers that are dedicated to the VLR. At the clarifiers, the activated sludge enters a center well and is slowed down to allow the sludge to settle to the bottom of the clarifier. A skimmer arm slowly collects grease and scum from the top of the water and scrapes it into a trough. The clear water leaves over the weirs of the clarifier while the sludge is pumped from the bottom to either be returned to the beginning of the treatment process or removed to a sludge holding tank. The sludge that is removed from the treatment process are microorganisms that can no longer treat the pollutants effectively. This sludge is sent to a sludge holding tank to thicken and remove excess water. Once water can no longer be removed from the sludge, it is sent to the biosolids building and ran through the belt filter press. On the belt filter press, the sludge is placed on a pair of filtered cloths and belts and is passed through a system of rollers. The belt filter press takes the sludge and squeezes the excess water to create a solid cake. The biosolids are placed in a roll-off dumpster and collected by a third-party vendor. The biosolids are further treated by the third-party vendor and then applied to farm fields as a substitute for fertilizer. The clear water that leaves over the weirs of the clarifiers is sent to the UV disinfection. The goal of UV disinfection is to render any remaining pathogens in the water incapable of reproducing and infecting. Pathogens are inactivated by the UV light as a result of damage to their nucleic acids. As little as 30 seconds of contact time is required for pathogens to be rendered incapable by the UV light. As the water exits the UV disinfection, it passes through a post-aeration basin that ensures ample oxygen levels are maintained before reaching the creek. The operation of these complex processes requires monitoring and testing on a continuous basis. Laboratory testing is used throughout the process to determine the quality of the water as it passes through each process and the quality of the sludge as it passes through the solids processing. Laboratory data is used to assure compliance with stringent state, local, and federal requirements. The processed water that leaves the plant is returned back to the environment in a cleaner state than the creek water. The cleaned water is discharged into Eagle Creek before heading to the Eagle Creek Reservoir. Clay Township treats and processes nearly 3 million gallons of water a day. Once the water has been placed back into the creek, the water cycle has been completed and the process can begin again.